problems we're looking to do? Yeah. All right. Remember when I said you can never get too much practice factoring? Well, in other words, you've had factoring quite a bit this year, but they're going to keep giving it to you because you can never get too much. Yeah. All right. Let's start with the first one. What is the first step? I'm going to insist upon using the technique that I've taught you, even though they may be actually teaching you a different technique in class. I'm still convinced that mine is the far easier one to understand.
All right. Well, first you need to find the greatest common factor.
Sorry, what? What's the first thing?
We need to find if there is a greatest common factor.
Okay. Is there?
No.
Okay. Is it difference of perfect squares?
No.
Okay. Notice number 2 is difference of perfect squares, but number 1 is not. So number 1 is a typical quadratic that you would have to factor. What's the first step in doing that?
We need to split up our x squared.
Good. And those split up x and x. What's the second step?
You need to find a number.
No, that's not the second step. Second step is determine both signs.
Yeah.
That's where I'm probably different than the way, because every single student I have, no matter how many times I teach them my method, they always forget the second step. So the only thing I can figure out is they're not teaching you that second step in school. But in my method, the second step is determine both signs. What do both signs have to be?
They both need to be minus.
Remember what factoring is. Factoring is the reverse of multiplying two things together by foiling.
Yeah.
So how can you possibly get a negative 16, which is the last step in foiling?
We need a plus and minus.
Okay, that's key. The signs have to be opposite. Now, the rest of it's actually pretty easy. What do you want? You want verbalize it.
We need to find the numbers that multiply 16.
And do what else?
That add the 6.
Not add.
Subtract the 6.
In this case, it's subtract because of that negative sign in front of the 16. If that was a positive sign, then they would have to add to 6. But if it's a negative sign, then they always have to subtract. Not to negative 6, but to 6.
Yeah.
What two factors is that?
8. No, so 8 and 2.
Okay. Which side does the 8 go on?
The left.
The what?
The left.
The larger of the two factors goes with the sign of the middle term.
Yeah.
Well, 8's our bigger factor, right?
Yeah.
So the 8 has to go with the minus sign.
Okay.
That's all you do, is you put the larger of your two factors with whatever the sign on the middle term is. Now, an important step that's going to come in when we do 4, 5, and 6 is checking to make sure we've done this right. Now, you don't have to completely refoil this. You could. In other words, I could just foil this times that and see if I get this, and you would. But really, there's a quick and dirty method of checking it, and that's by doing just the O and the I of FOIL, the inside and the outside. Multiply those two, multiply the outside, add them together, see if that's the middle term you have. And it is. So we did it right. Okay. Next one. Factor that. I won't even write it because I hope you can just tell it to me. Number 2.
We're going to have x and x in the parentheses.
This is difference of perfect squares. So you're not going to do this quite the same way. In other words, once you recognize that it's difference of perfect squares, you should be able to do it in an instant. It's the square root of the first term minus the square root of the second term times its conjugate, x plus 4. In other words, you really only have to figure out that term. The second term is automatic. Once you get the first term figured out, the second term is always the conjugate of the first when you're dealing with difference of perfect squares. And notice what happens if I were to FOIL that out and apply my test. The middle term completely goes away. That's why you don't have a middle term here. The only thing you have is x times x, which is x squared, and minus 4 times plus 4, which is minus 16.
Yes.
Do this one step by step.
So we're going to have the x's, and both sides are going to be plus. And it's going to be
Factors of what? That do what?
36, but add 13.
Okay.
And there's 6, 7.
6 times 7 is not 36. They have to multiply to 36. In other words, it has to be factors of 36. So let me help you figuring out what factors are when you have a big number. Start there. Now, next thing you do is you see if you can cut 36 in half. I can, which means I got to double the other one. Now, can I cut it in half again? 18, yes. Which means I got to double the other one. Ooh, I have my two factors, 9 and 4. And this is only 3 steps because you don't have to figure out which side the 9 goes with and which side the 4 goes with. So that's a 2-step factoring problem.
Yeah.
Okay, now we get into a little more difficult ones. And first of all, let me back up a step. Let me just back up because it says solve these. It doesn't say just factor them. Okay? So I had x plus 4 times x plus 9 in the previous problem. What are my two answers for x?
13 and
If x plus 4 times x plus 9 equals 0, what has to be true?
x is 0.
No. These are both 0. And the way you solve this equation is by setting x plus 4 equals 0, solve that, and then set x plus 9 equals 0 and solve that. So the first one, x ends up being minus 4. Second one, x ends up being minus 9. So there's your two solutions. Okay? And don't make the mistake of always assuming that it's the negative of this. In other words, if I had 2x plus 4 was one of the factors, well now it's 2x plus 4 that's equal to 0, and x would actually be minus 4 divided by 2. So it isn't always just the negative of that term. It is if it's just an x, but if it's some number of x greater than 1, then you have to actually do the algebra and solve it. Okay? All right. Now let's look at this next one. All right. Now, these problems are a bit of trial and error, but not that much trial and error. Not so much that it's that hard to do. Split the x's up. What do you get?
You get 1x, or you get, wouldn't that be x squared?
Well, we're not looking at x squared. We're looking at 2x squared. So you got to split them up such that they multiply together to give you 2x squared. 1x times 2x. I could also write 2x times 1x. But the key is you got to split them up in a way that when they multiply back together, they give you that first term. Okay? Now, what are both signs? The second step is still the same, kind of. What are both signs? Okay. Now you cannot use any of the same rules. You cannot say factors of 15 that add to 13. That's out the window. That's out the window the moment you have something other than x and x. In other words, if you have x times 2x or 3x or whatever, if it's not x and x, then you cannot use that rule on these problems. However, how many factors of 15 are there? How do you factor 15? I can't cut it in half. Can you cut it in a third? Yes. That's the only other two factors. Okay. Now, when I say it's a trial and error process, no, I don't know yet. I never know until I actually do it. I do it the same way I teach it. I just try. Okay, now the first factors I'm always going to try are the two that are closest together. That's just the way they make these problems. So I'm going to try a 3 there and a 5 there randomly. I don't have any rhyme or reason. I'm just going to try 5 and 3 or 3 and 5. Does that produce the proper middle term? That's always the question when you're dealing with these harder ones. Are we producing, in other words, I know I'm producing the 2x squared and I know I'm producing the 15. The question is am I producing 13x in the middle? Well, how do I figure it out? Do the O and the I. In other words, for these harder ones, this is not just a checking process. This is part of the process for figuring out the answer. Does that work? 6 and 5 add to 13? Okay, let's try another combination. Well, the only other combination, the next one I'm always going to try is the reverse, 5 and 3. Does that work? Well, that's 10x on the inside, 3x on the outside. Add them together, you get 13x. That's how I know I did it right. Always have to be doing the check using the O and the I of FOIL. So that is the correct answer there. In other words, that's all the checking I need to do in my mind. If my life depended on it, I would go ahead and FOIL these and make sure that after the foiling and simplification, I had this, what I'm starting with. But I'm 99.9% sure of my answer the moment I do check the O and the I of FOIL. Now, what is my solutions? And you almost always have two solutions when you're dealing with quadratics. If you were dealing with cubics, you would have three solutions. If you're dealing with a linear, you'll only have one solution. So you usually have as many solutions as the degree of the polynomial. What's the first solution? It's pretty easy. You get it by solving this. Set that left term equal to 0 and solve. If x plus 5 equals 0, what does x equal? -5. Okay, -5. You cannot drop a negative sign and hope that nobody notices. If you drop a negative sign, you're missing the problem. That's as bad as doing any other mistake you can make. Now, the second one, we're going to set 2x plus 3 equal to 0. Solve that. -3/2. Don't turn stuff into decimals just because you can. This is a far preferable answer. It just is. It's hard for me to explain why, but there's no need. In other words, notice that when you do the math, you get 3/2. You don't get 1.5, right? I mean, unless you do it in a calculator, but there's no need to do it in the calculator. You can move the 3 over there and divide both sides by 2, and this is the answer you get. And this is really the proper answer. I mean, -1.5 would also be correct. You're not going to lose points on it, but just trust me, you're better off leaving these things as improper fractions. Okay, let's look at number 5. 12x squared. Now, the bigger these coefficients in front of the x squared, the harder the problem is. But what's the first step on this problem? Yes. Is there one here?
Yes.
What is it? 4. 14 doesn't divide by 4.
Yeah, so
2. You know, at least I can take a 2 out. What's left over?
6x plus.
Hold on. Let me stop you for a moment. The secret of math is always be checking. Don't wait and factor the entire thing out and then check. Check term by term. In other words, I know 6x squared is correct because 2 times 6x squared is 12x squared. So I know I've done it correctly immediately. I don't wait until I'm done to check. I check it as I'm doing it.
Yeah.
What's the second term? And the third term?
2.
Plus 2. All right, so now we're going to factor this quadratic using the same methods we've been using. And again, because we have a 6, that makes it fairly hard. But notice that the 2 only has one set of factors, 2 and 1. So even though this is a little difficult, it's not that difficult. What's the most common way you would factor 6x squared?
Into 3x squared.
Always got to split the x's up.
Yeah.
In other words, I don't want to write 3x squared here and 2 over here. That's not factoring. In other words, that's why part of what the first step is split up the x's. Not just the coefficient, but the x's also. Always split those up. And I know that 3x times 2x is 6x squared. Now, both signs. All right. Now it's strictly trial and error. I've either got a 2 here on the left and a 1 on the right, or the reverse. That's my only choices. Okay, well, let me try 1 there and 2 there. Does that produce the proper middle term of 7x? You want to get pretty good at this step here, because this step here is involved every time you're figuring out one of these harder quadratics to factor. So get in the habit of being able to multiply those two together and those two together. Use what I call my double smiley face method. Does that produce 7x when you multiply those together and add the results?
Yeah.
Well, this is 2x, that's 6x. Does that add to 7x? Okay. Let's do the only other possibility, which is a 2 here and a 1 here. Now do it. That's 4x, that's 3x, both plus, add them together, that's 7x. That tells me I've done it properly. Okay, so that's a huge part of factoring, is doing that inside and outside. Now give me the solutions to this. What is x equal to? Notice that this leading 2 is no longer even important. I can divide both sides of the equation by 2 at this point.
Yeah.
However, I got 3 things multiplied together here. I got this times that, and it's equal to 0. That means that that could be 0 or that could be 0. The 2 certainly can't be 0. So either of these have to be 0. At least one of them has to be 0. Well, you always solve it by setting both of them equal to 0 and then solving. Okay. So when I set the first one equal to 0, what do I get for x? Leave it in a ratio.
So the first one you get is it 2/3?
Minus 2/3. Tell you what, I'm going to write it out until you get so you can do those quicker. So I'm going to say 3x plus 2 equals 0. Now solve that step by step. What's the first step?
We need to find out what x is.
No? Yeah, but how do you solve an equation? If I'm trying to get x all by itself, what do I got? I got to get rid of the 2, right?
Yeah.
How do I get rid of that plus 2?
Subtract it by both sides.
Okay, so that's my next step. Now I got to get rid of the 3. How do I get rid of the 3?
Divide 3 by both sides.
So there's your answer, minus 2/3.
Alright.
That's for that one. Now I also have 2x plus 1 equals 0. Solve that.
That would be it'd be negative half. No, minus 1/2.
Good. There's your 2 answers. Notice that I didn't care whether that number was a 2, a 7, or a million. It does not affect my answers. In other words, what I really can do with this equation is immediately divide both sides by 2. Well, that gets rid of the 2 over there, and it leaves the right side at 0. 0 divided by 2 is still 0. So I can simplify it by just deleting the 2. Actually, it turns into a 1. When I divide both sides by 2, this turns into a 1, but I don't need to write it.
Yeah.
All right. All right, let's try some more of these tough ones. And I call something tough whenever it is not an elementary one. By an elementary one, I mean x squared only. If it's x squared only, then I can use my 3 steps and it works every single time, and it is absolutely the easiest way to go.
Yeah.
When it's not elementary, let's call these secondary in terms of difficulty, well, then I'm going to use the first 2 steps, but then I'm going to use what I call a little trial and error. And that's no different than what they teach you. I don't know if they taught you the California method or the diamond method, but both of those have trial and error in them also. Okay? So this is nothing really new. So what's the first step? Okay, split them up.
X and 3x.
What's the next step? Same first step, same second step. Determine both signs. What are they?
Plus and minus.
If they were plus and minus, let's say you were correct. Well, there's no way you can produce a plus 8 from that. No matter what numbers I put in here, plus times minus is always minus. So the first thing you have to do to determine the signs is check the sign in front of the constant. It's a plus. That means both signs are the same. That's all it means. Now, to determine whether they're plus plus or minus minus, it's one of those 2 cases, look to the sign of the middle term. The middle term is negative. Therefore, it has to be minus minus. That's all you need to do. In other words, once you've determined that both signs are the same, just check the sign on the middle term. Okay, now let's list factors of 8, starting with that one. What's the next one?
So it's 8 and 1, it's 4 and 2, and that's it.
Well, I could cut this in half again and double that, but that's the same factors.
Yeah.
So I'm not going to just reproduce the same factors. Those are the only 2 sets of factors for 8. Well, what do? I always initially try the 2 that are closest together. 4 is closer to 2 than 8 is to 1.
Yeah.
Okay? So just automatically, I'm going to try 4 there and 2 there, and if that doesn't work, then I'm going to try 2 and 4. Does this work? What's that equal to?
1x.
Multiplication, not subtraction.
Oh. 4 minus 4x.
And what is that equal to?
Minus 2x.
Add them together.
Minus 14x.
We got it. Now solve for x.
Alright.
What's the first one? Whenever you're looking at this, where the x doesn't have a coefficient in front of it other than 1, then the solution is always just the opposite of this number. So I can just say x is equal to 4.
Yeah.
Second one, a little harder because it's got a number in front of the x. So I start out by doing that. And you don't have to do these in one step. You can write this and then just solve it like an equation. I know you know how to solve this equation. What's the first step in solving it?
Subtract 2 by each side. No, add 2 each side. The x equals 2 and divide each side by 3 and x equals positive 2/3.
Okay, there's one answer, there's the other answer. And if we were to check and plug both of these in, we would find that that is an equation with both answers. And by that I mean the left side is going to equal the right side. It's a proper equation. If you ever are checking your answers and you don't get this to equal 0, then you've made a mistake somewhere. In other words, these always have to satisfy the equation you started with. All right.
We're not supposed to do 7 and 8 tonight.
Okay. That's because they don't factor well.
Yeah.
We'll just look at 7 for a second. And it's not going to hurt you to do them because you're going to get into it immediately. Okay. If I didn't know, and I don't until I begin the process, I don't know that this doesn't factor, so I'm going to try to factor it. Well, it's x and x. Both signs are plus. Now I need factors of 10 that add, because of that plus sign, to the number 11. 10 and 1 actually work pretty good. I don't have to use the quadratic formula. In other words, I end up getting the two solutions just normally. However, let's talk about the quadratic formula since we can get a little ahead. They're going to introduce you to the quadratic formula very soon. Let's say that instead of a 10, that's a 9. Now, notice that there are no factors of 9 that add to 11. 9 and 1 don't, 3 and 3 don't. If you cannot factor it in the same way that we've factored everything else, then you have to use the quadratic formula. Okay, and here's the quadratic formula. And I'm not sure how they... Do you have this memorized by any chance?
I think so.
Go ahead. If you have it memorized, don't read it off of a piece of paper.
So I think it's x equals minus b minus the square root.
Plus or minus. There's that plus or minus immediately. Then it's square root. What's inside the square root? B squared minus 4AC. That's actually got a name. That's called the discriminant. There's a reason why it has a name. Is a lot of times our very first step is to solve the discriminant and see if b squared minus 4ac is a positive or a negative number. Because if it's a negative number, notice I can't take the square root of a negative number without bringing imaginary numbers into the equation. And if you have to do that, you have to do that. But, okay, in this problem, plus 9, that problem, tell me what A, B, and C are.
A is 1, B is 11, and C is 9.
So, plug it into the quadratic. Let's solve it.
Alright, we have minus 11
Plus or minus. Plus or minus is very important because that's going to give you your second solution. If you just do plus, you're only going to get one solution. And always remember that quadratics are almost always going to give you two solutions. B squared is 121. And then I highly recommend doing this step exactly like this. Don't take any shortcuts. Do it exactly like that. Okay? And the reason is that this can end up being very confusing sometimes, the discriminant, especially if C is negative. In other words, if I were to stick a negative in front of that 9, now all of a sudden it confuses everybody. This particular one isn't going to be that confusing because it simplifies rather easily. 121 minus 36 is 85. All over 2. And when I say that is the answer, what I really mean is the following. And this isn't always clear to everybody either. It means x is equal to minus 11 plus root 85 over 2, or x equals minus 11 minus root 85 over 2. That's what the plus or minus means, is you have two different solutions. One uses the plus, the other uses the minus. And these are definitely two different numbers. And that's actually the correct way to write it. I can't really simplify root 85. There's no perfect square numbers that divide into that. And I don't want to convert it to a decimal. So if Albert Einstein were to come back from the grave and say, what's the answer to this problem? I've circled it. The two bottom circled are the two answers in the best format you can write it, the most accurate. Okay. Now, let's just look at the second one. Do you have more beyond this? Is there other pages or anything?
No.
All right. Since it said solve using the quadratic formula, I'm not even going to attempt to factor it. Number 7, I was actually able to factor. I didn't have to use. Generally, you only use the quadratic formula if you have to. In other words, if you can factor it in a normal way, then the quadratic formula is the far harder way to do it. Unless the problem specifically says use the quadratic formula. So give me the general again. I'm just going to keep asking you for the general until you have it memorized. And that's the way to memorize anything. In other words, if you had it written on a sheet of paper and you were just always reading it, guess what? You're not going to have it memorized in 6 months.
So it's minus b plus or minus.
Think of it as the square root of the discriminant. The discriminant's what's inside. What is the discriminant in terms of A, B, and C?
B squared minus 4ac.
Correct. And then it's all over 2a. Now, I don't know if they ever taught you how to find the vertex,
No.
but the vertex is minus b over 2a. So if you learn how to find the vertex by minus b over 2a, it kind of helps memorizing the quadratic formula, and vice versa. If you know the quadratic formula, then you know that you get the vertex by taking the first half of it.
Yeah.
Okay, now fill it in.
Alright, so 13 plus or minus, what's the
169.
169.
That's 13 squared. And notice that it's always positive. Even though b is minus 13, when you square a negative number, it turns positive. So b squared is always positive.
Yeah.
How should I write the rest of it?
Minus 4 parentheses 4 parentheses 3 over 2.
Not over 2, over 2a, which is 8.
Over 8.
Yeah. Now it's easy enough to simplify the inside, I think. Let's see, 4 times 4 times 3 is 48. 169 minus 48 is 121. That turns out to be a perfect square number. And when you use the quadratic formula and you end up with answers like we're going to get here, in other words, this is 13 plus or minus square root of 121 is 11. Well, 13 plus 11 is 24 divided by 8. There's one answer. 13 minus 11 is 2 divided by 8. There's another answer. And what that tells me, since I don't have any radical signs in my answers, is that I could have factored it all along. Yeah. It must have factored into x minus 3 times 4x minus 1. Yeah. If I would have tried to factor number 8, without using the quadratic formula, I would have gotten those two factors. Notice that those two factors give me these two answers. And it probably would have been easier to try to factor it. It wouldn't have been that hard to factor. Only reason I didn't even try was because the instructions said use the quadratic formula. Okay. Let's talk about the discriminant for a moment. Why is this so important that it has its own name? Reason is, if it's greater than 0, just the discriminant, that means you have two real solutions. If it's equal to 0, you have one real solution only. And if it's less than 0, you always only have two imaginary solutions. Have they taught you imaginary numbers yet? No. Okay, well, they're probably not going to give you very many quadratics that result in two imaginary solutions then, because they haven't taught you imaginary numbers. So you really can't do much with imaginary solutions. But notice that if it's less than 0, that means I'm going to have a negative number in there, like -4. Well, the square root of -4 is 2i. That's imaginary numbers. In other words, as long as I can use imaginary numbers, I can take the square root of a negative number. But I've got to use imaginary numbers to do it. And they're imaginary, just like imaginary friends. They're not real. They're used strictly as a mathematical tool for doing higher mathematics. So they exist because it helps mathematicians do harder problems. But they're not real. There are no two numbers that multiply together to give you -4 that are the same. And that's what taking the square root means, is you have to find a number times itself that's equal to what's inside the radical sign. So every problem that you get for the moment is always going to have a positive discriminant. And the reason I told you the reason I said write it the way is because a lot of times you'll get something like this. Let's see, last time, let's do this. 121 minus 4 times 1 times -9. Let's say that was it. Now, that is confusing because I'm looking at two minus signs. One of them means subtraction, the first one, But the second one just means minus 9. There's no subtraction going on at all. In other words, if I try to simplify this, I get 121 plus 36. And I recommend everybody do those 3 multiplications first. Not minus 4, but that right there. That way you'll never make a mistake with your signs. And it's very easy to make a mistake with the signs here. In other words, you could do minus 4 times minus 9, you get plus 36, which it turns out to be right, but I am a firm believer that you want to do what I've got in the square and the rectangle there, you want to do that step first, always. Multiply, and so what I really am going to have is 121 minus a minus 36, which turns into 121 plus 36. But it's very, very easy to get the signs wrong if you don't do it exactly in this manner here. And then the next step is you don't want to do those 4. You want to do those 3. Multiply those 3 numbers together. Because you're frequently going to be subtracting a negative number which turns into addition.
Yeah.
All right. Nick, there anything else that we need to take a look at?
I'm good.
Not today?
Not today.
Okay. Well, I will let you go.
Alright, sounds good.
All right. Talk to you next Wednesday. Have a good week.
You too. Bye-bye.
Bye-bye.